Hello and welcome to Algebra 2 tutorial. In this video we're going to take a look at some characteristics of polynomials. Mainly we're going to be taking a look at polynomials' end behavior, when are they increasing and decreasing, and then how can we use that information to sketch a graph of a polynomial function. First though, let's make sure we understand what we mean by a polynomial. So a polynomial is basically just a string of terms that are either adding and subtracting. So here we have an example of one term by itself, and because there's only one, we call that a monomial. If you put two of them together, so here is one term and here is another term, that is called a binomial. Bi, of course, means two. And if you have three, trinomial. You can see here we have three different terms. If you go more than that, we don't really keep going with the prefixes, we just call them polynomial, which means many, and that's also a blanket term for all of these. So once you get past three terms, we just refer to them all as polynomials. And so we're going to look at the characteristics of what would happen when you graph these, and how we can look at those characteristics in their equations. So the first characteristic that we're going to look at is end behavior. Now, end behavior has two different categories. There is a certain type of end behavior if your polynomial has an even degree, and there's a certain end behavior if you have an odd degree. So we're going to start with even. That's actually what we're most familiar with. And so here are some equations that have an even degree as their highest power. And so this is an even degree polynomial. Here we have a squared, a fourth, or a sixth. Anywhere where the highest power is even, that is an even degree polynomial. And we group them all together because they have the same end behavior. So let's start with the one we know, y equals x squared. We've been looking at that for a long time. We know that that makes a parabola, something kind of like that. And end behavior is simply describing what these arrows are doing. All right? As you go to the end of the graph, what are those two arrows doing? Well, the arrows are going up and up and up towards what we say positive infinity. And so the way we describe that, we think of a person, again, walking to the left. As that person walks to the left, they would go up and up and up forever. And the way we do that mathematically is we say as x approaches negative infinity. So that is walking to the left. Y, our y values, so where do our y values go? They are also going towards positive infinity. They're going up. All right, now we think of our little person walking to the right. So that means x is going towards positive numbers, so positive infinity. What's happening to our y values? Well, again, our y values are going up and up forever, so our y values are going towards positive infinity. So we just described the end behavior of y equals x squared. Let's do the next one, this one. That's also a quadratic that we are familiar with. Now, I'm not going to draw a perfect graph of this. Actually, I'm not even going to put the x and y axis because I don't even know where they are. The one thing I know about this parabola, though, is that it is going down. The negative 5 flips this parabola upside down. And so it doesn't even matter where the x and y axis are. I just want to know, as this person walks to the left, they will be going down. And as this person walks to the right, they will also be going down. So the end behavior, as x approaches negative infinity, that's going to the left, our y values are also going towards negative infinity. And then as x goes the other direction towards positive infinity, the y values are going towards positive infinity. Sorry, negative infinity. Let's fix that. both the y values are going down as we go out to the ends. So those are the two that we are familiar with. Let's do the ones that we're less familiar with. All right, we haven't done much with 4th degree or 6th degree polynomials yet, so we need some help. Let's do the harder one, the 6th degree polynomial. So here is a graph of that 6th degree polynomial. We're doing this one right here. And as you can see, it's quite complicated. It has lots of ups and downs and ups and downs, but we're not worried about all of those ups and downs. We're just worried about the end. What are we doing at the end? And you can see that these arrows are familiar. They're exactly the same as this one. So as x goes to -infinity, that would be this way, our arrows are going down. So our y values are going towards -infinity. And as x goes to +infinity, that would be going this way. Our y values are going towards -infinity. The arrows are pointing the same direction. And so this other one, I'm not going to do it, but we can think of it really easily because all of these are going to be similar. Because it's a positive number in front, it will be looking something like this. Now, yes, it will go up and down in the middle, but we're not worried about the middle, just the end. And so these two arrows, this end behavior will be just like this one. And so all the even degree polynomials have very, very similar end behavior. The arrows are either going down on both ends or they are going up on both ends. So that's a quick overview of even degree polynomials. Let's take a look at odd degree. These ones we're much less familiar with, but you'll see that they have some big similarities also. So the most simple is y equals x. So if I were to draw a quick graph of y equals x, it's linear, and it is technically an odd degree polynomial because this is x to the first power. And so now you can see the arrows are going in opposite directions. This one's pointing down, and this one is pointing up. So our first end behavior, as x goes to -infinity, our y values go to positive, or sorry, again I messed that up, sorry about that, -infinity. And as x goes to +infinity, that is this direction, we are going up, so this time y is going towards +infinity. You can see the arrows are pointing opposite directions. All right, let's do the very simple cubic. Now, if you're not familiar with this parent function, I will draw a quick graph of what it looks like. It starts way down here, it flattens out, and then it goes up. But as you can see, the end behavior, the arrows, are exactly the same as that one. And so the end behavior is going to be exactly the same. So I won't write it, but the end behavior is exactly the same. Even though the middle is different, the ending arrows are pointing in the same direction. So let's do a hard one now. This one, -3x to the 5th, and lots of other stuff. Hopefully you might start to be able to predict what this negative is going to do. Give me a slightly bigger one here. So this one, again, we're going to need some help, however. So here is a graph of this equation right here. As you can see, it has some ups and downs in the middle, but we are only concerned with the ends. So there are the two arrows, and so now we describe them. So first we're going to go to the left as x approaches -infinity. infinity. That is going to the left. So in that case, our y values are going up, so our y values are going towards positive infinity. And then when we go to the right, that will be this way. As x goes towards the positive direction, positive infinity, our y values are going towards, well, they're going down, so negative infinity. Now again, you can see it's similar, but this time the arrows have been flipped. The one on the left is going up, and the one on the right is going down. So if we want to do that last one real quick, this one, now I don't know exactly what that graph looks like, but I know because there's no negative here, it's not going to be flipped. So it's going to go from bottom left to top right. Now it's going to do some squiggling in the middle. I think it's going to look something like that. But as we go towards negative infinity on our x, our y values are going down, and as x goes to positive infinity, our y's are also going towards positive infinity. And then with this one, that negative flipped them. Okay? So if your first degree is positive, that's what you look like. If that first term is negative, it will look something like that. You can see they are both just flipped. All right, so that's our end behavior of odd degree polynomials. So overall end behavior, the even degrees look the same. If they're positive, they both go up. If they're negative, they both go down. Odd degrees are also similar to each other. If they're positive and negative, they just flip from each other. All right, but they are diagonals. All right, so that's end behavior. Let's next take a look at increasing versus decreasing. Another way of describing polynomials. So here we have a nice polynomial graph. I even gave us the equation. And what we're interested in is describing where is this graph increasing or decreasing. Now this is a little confusing after what we just did, because I know in the previous one our little person walked left and our little person walked right. But when you're talking about increasing and decreasing, you only walk to the right. So you start off over here, here's our little person, and this little person just walks along the graph. So as this person is walking along the graph, they're going up. So they are increasing. And then right about here at the top of the mountain, now this person starts going down. They are decreasing. And then here's the bottom of the valley, and after that, they start to go up again. So as we describe this, we're increasing, then we're decreasing, and then we're increasing. And so we want to describe all of those places. So this little person, let's first describe increasing. So f is increasing, and we call these intervals. Over the intervals, now this person, where does this person start increasing? Well, this goes down here forever, so there's no real starting point. They start down here at infinity. And so we start at negative infinity. So you think way over here is negative infinity on our x-axis. And they're walking up, they're walking up, they're walking up. Where do they stop walking up? Right here at negative 2. That's where they stop walking up. Then they go down. We don't want to talk about that yet, but then they start going up. I'm only talking about the increasing. So we have another excuse me, another interval where they're going up. And we use this fancy symbol right here. It's called union. It's kind of like the word and they start at 1. And at 1, they start going up. And how long do they go up? Well, forever. As long as the x-axis goes this way, this person is still going up, so they go all the way to infinity. All right, let's do our decreasing interval now. F is decreasing. And let's keep our sentence going over the interval. Oops. All right, so where are we decreasing? We start right here, so that is at -2. And we end our decreasing right here, which is at +1. There we go. So, one of the confusing things about this is we always use the x-axis. You can see that my answers are always x numbers, x numbers, x numbers. Even positive infinity over here is an x number. So these are all x values. We don't use the y. That's confusing for a lot of people, but that's the way it's done. If I want to say, hey, where is this point right here? It's at -2. We don't want to use the y values. One quick reason why is the y value 10 happens multiple times. And so if I say a y value of 10, you don't know which one I'm talking about. But the x value -2 only happens once. That's a property of being a function. So that's why we use the x values and not the y values. All right, so that's increasing and decreasing. You want to be able to describe those using interval notation. So our last topic here is graph sketching. Now that we put all this information together, that tells us a lot about a graph. We should be able to sketch it with that information. So that's what we're going to try to do. So we're going to sketch the graph of a function, f of x, where we have some end behavior. As x goes to infinity, y goes to -infinity. So I'm going to sketch this here. Here's my graph. As x goes to positive infinity, that means going to the right. Y goes to -infinity, down. So that means this arrow down here will be going down. As x goes to -infinity, so that's this way, y also goes to -infinity, so that's down this way. That means this arrow will also be down. Now what happens in the middle? So hopefully they give us some more. So f of x is increasing from -infinity all the way to the number 4. So from way over here, -infinity, all the way to the number 4, this graph has to be going up. So if I start way down here, I have to go up, 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 until I get to 4 somewhere. I'm just going to go up here. That's when we start to, it looks like we're going to start to decrease. So now, do I know how high this point is? No. There's not enough information, so I just picked a random point up here. And so it comes like this, match up with that arrow. So as you can see, this is increasing, increasing, increasing to here. And then from 4 to forever, so from 4 to forever, we now have to be going down. I kind of messed that up, didn't I? Let's try to make that the top. Now we're going to go down. Now I'm not quite matching it with my arrow, but that's okay. This arrow is still showing me the same information, so don't worry about matching up with your initial arrows. And so now we have a sketch of what this graph could look like using the information that we were given. Alright, so there we had a quick introduction to polynomials and 3 different characteristics and things you can do with them. So to practice that a little bit, here's a few problems. Good luck to you.